Well, hope you're having a good Thursday evening. We're back for our forecast livecast, and check this out. Halo phenomena going on. See that right there to the left of the sun? That's a sundog. That's being caused by kind of a uniform distribution of plate crystals up in that cirrus that you see there. Very cold temperatures up there, like minus 40, minus 50. And off to the east, got a few thunderstorms out there. Things have really gone to town in East Texas and Louisiana. And I can show that to you here on the SPC mesoscale analysis. Quite a mess we have here. In fact, it goes all the way up to Little Rock and all the way back down to Lake Charles and Alexandria. So pretty large area. Have another area out in the Oklahoma region and into the Amarillo I-40 area, and that's being caused by this frontal boundary up to the north. So the dominant weather picture we have for today is southeasterly flow coming up from the Gulf, hitting this outflow boundary or this front, and then north of that we have this northeasterly flow. So it's a relatively simple pattern, and we can actually see that here on this pressure analysis, so maybe we can draw that a little bit. Losing my voice here, a little bit further south. So you see how this falls in that inverted trough. In fact, maybe we can even carry it up this way a little bit. And that's the reason we would do surface analysis, to really pick that out. Off to the east we can see a meso-high. So see that right there over Monroe. Seems like sometimes I come on here and I lose my voice, and other times I don't. But yeah, there's the meso-high, and we can definitely assume that that's got a outflow pool surrounding it. Probably something, if we went and looked at the surface analysis, we would find something like that. So what do we got going on in the satellite picture? Well, this time of year it's good to use the water vapor imagery. And this definitely shows that MCS out in Louisiana and Arkansas. And we're not going to see so much of the low-level moisture because it's being obscured by higher cirrus. And again, it's not very sensitive to the low levels of the atmosphere. It does look like a little bit of the monsoon has moved up into the southern Rockies. So we're seeing a few cells out there in the Four Corners area. And even some down towards northwest Mexico. I forgot all the names out here. Hermosillo, maybe. I probably have to study up on some of those cities down there. Now, as far as watches and warnings, looks like we got flood watches up for Kansas and severe watches up for the Texas Panhandle. And look what's back here in the Pacific Northwest. I'm sure they're not happy about that. Looks like a heat advisory. Temperatures up in Seattle, 91. And look at that, 90 here north of Victoria. 88 at Victoria itself. 79 in Vancouver. Actually, and then we got 91 inland. And I'm trying to remember the city names up there. I can't recall. There's anyway, yeah, just go a short distance inland and we got this heat really cranked up. 94 there at Portland, 95. We're not seeing that 108 that we had last week. That was kind of crazy, but this is definitely some very warm stuff. And you can see the onshore flow here at Astoria. If you're standing there on the beach, you think you're going to have like nice warm, nice cool temperatures come in from the Pacific. We got 84 there, so we can definitely assume that we've got a large area of subsidence and adiabatic warming working on this area, and we might be able to see that on the upper level charts. If we go further east, we can see high pressure over Minnesota and Iowa, and that's driving that northerly flow down into Kansas, and then we start picking up some upslope flow in Colorado and western Nebraska. And I don't think anything is really going on up in the northeast, but maybe I can pull that up and we'll just take a quick look. I'll pull up the Albany sector. Looks like just southerly flow across New York and Connecticut, and Looks like we're starting to pick up a little bit of outflow, maybe around here, around Buffalo, Syracuse, Rochester, and back towards southern Ontario there. So there's probably an old frontal boundary that divides this lower 80s temperatures from the cooler low 70s up here. And the dew points are a little bit cooler up north, or a little bit less moist. Dew points are in the low to mid 60s up in Ontario and Quebec, compared with lower 70s in Pennsylvania and New York and Connecticut and Massachusetts and all that. I think I had some radar up here. Let me pull that up. I decided to bring up one sector for us to look at. It's good to do that when there's significant weather. This is Springfield, Missouri. So this is along that frontal boundary, and we can see that outflow right there. So that goes from about Branson up to Lebanon, Missouri. And we can switch over to spectrum width and definitely see that right there. Sometimes we pick it up very well and sometimes we don't. Here it's very vague, but out here I can definitely see it. Let's look at the base velocity. What does that show us? Always keep in mind that your red warm shades are always positive, which always means outbound velocities, so moving away from the radar. And in contrast, your flow that's bluish or greenish and is a cool shade, that's coming towards the radar, and that's going to be a negative velocity. So that's a relationship you always want to keep in mind. So let's start with the radar site itself. We can see the radar site pretty easily right there because of that circle, and we know that that's Springfield. So what do we have right around the radar site? Well, let's consider this small area here. Well, we've got green to the northeast of the radar site and red to the southwest. So that tells us we probably have inbound here and outbound there. So we're painting out a northeasterly flow across the radar site that's blowing in from this convection. probably the remains of the storm that's north of Springfield. Just a moment. Had a cough there and I don't want to blow out the mic, but let's get back into it, shall we? Okay. Now keep in mind that when we get further from the radar site, we get into higher and higher altitudes because the radar beam goes outwards and upwards like that. So it kind of forms a cone around the radar. So if we want to look at the upper level winds, all we have to do is move away from the radar. We can consider maybe the area around this big circle I'm drawing. So we can see that as we get further away from the radar and into these higher areas, instead of outbound, we're seeing inbound. So let me trace that from along this radial here. So we go out from the radar site, we're up to, let me show you the altitude readout right here. See that altitude readout right here? So keep an eye on that as I move away from the radar site. We go from 0. As we pass through the red, we're up to 200 feet. And as we get out to 600 feet, we have a change because we're emerging above the outflow area. Now we're getting into the green, which means inflow. This is the southerly tropical air just above the outflow bubble. And it's moving across the radar site, but you have to go up to a higher altitude to see that. So up above, southerly flow, and down below, northeasterly flow. So you kind of see what's going on there. Now as far as velocities inside the storm, I don't really see a whole lot going on. What I'm looking at is the intensity of the shades, and the only one that really stands out is this cell right here. So if I wanted to analyze for severe weather, I might take a closer look at this area. So there's probably a little bit of a downburst going on, and that's probably triggering that severe thunderstorm warning. So remember, red is going to be outbound. So this is probably blowing this way. So that's going to correspond to probably the backside of that storm. So that's the outflow going away from the core of the storm. And then on the forward end, we're going to see some inflow towards the radar. So kind of what we're painting out is sort of like an outflow area like that. All right, let's see. That's probably about all I want to do for the radar. So let's go ahead and move ahead. What do we have next? Oh, we have the tropical storm stuff. We have this disturbance moving north of Guantanamo, the southern Bahamas, and it's starting to track up towards the Key West and Homestead, Cape Coral area of Florida. And that's going to carry it into the Gulf, it looks like, so that'll probably be a factor coming up for next week. We're going to return to that in just a minute, but let's take a look at the big picture 250 millibar flow. Starting out at 0 hours, here we go. Long wave across the western U.S. The stronger upper level flow is across the Great Lakes. So the polar front jet is up north like that, and south of that, subtropical jet across California and Arizona. And then advancing forward 24 to 48 hours, you can see that even though we have a bunch of waves moving west to east, the large long wave trough kind of stays in place, like the larger scale broad trough that kind of hangs in there. So that's going to keep the precipitation chances up over the next week or so across most of the western U.S. So we get a couple waves moving through there and another huge one digging off the west coast, getting out towards September 2nd, September 3rd. So maybe they'll get some rain in California coming up here next week, or maybe the week after. That's a pretty deep trough right there in Nevada. And look what's coming in on the backside. Again, this is getting way out there, but you can see we've got 130, 150 knot winds coming into the backside of the trough. When that happens, you're going to end up digging that trough further. So if this pans out, I would expect this low to continue digging into New Mexico, and that could be a really big weather maker for the southern and central plains. That could even give us our first big severe weather outbreak of the season, of the fall season. But that's a long ways off, so we'll not worry about that too much. Anyway, I wanted to cover thickness a little bit because I've been missing that over the past couple of days. This is a thickness chart from a website called wxmaps.org. So we'll take a look at this maybe over the next few days. Now the colored lines that you see here, these are sea level pressure lines. And then the orange shading with very faint lines, that's going to be your thickness field. So you see the thickness scale here? We're mostly dealing in the orange colors because it's a very warm time of the year. So if I draw the thickness lines, they're going to look kind of like this. There's one line, we have another line here, and another line up here. So kind of keep that in mind as we look through this chart. Now, what is thickness? Let me sketch something here very quickly. Thickness is going to, that corresponds to the distance in the vertical between two pressure surfaces. Keep in mind that this is going to be, we're looking at the ground here. As you go to higher heights, the pressure tends to diminish as you go upwards. So we go from 1,000 millibars at the surface. By the time we get up to about 5 kilometers, it drops to 500 millibars. I really need to dig out my sketch tablet. This might go a little bit better. But thickness is basically the distance between those pressure surfaces. And that's going to be a function of density, or to be a little bit more accurate, temperature. The cooler the temperature, the average temperature, the lower the thickness. So that's going to bring the distance between those surfaces even closer together. So say we have a cold air mass here. I'm going to put K for cold air mass. And okay, what did I hit? Let's try that again. Okay, K for cold air mass. W for warm air mass. So the first thing I'm going to do is draw the thickness. I'm over here hunting for the black color here, so let me try again. Okay. K for cold, W for warm. I guess I'll use orange here. Okay, the 1000 millibar surface may look something like that, for example. Now, since the thickness is less in the cold air mass, you're not going to have to go quite up as high to reach the 500 millibar surface, so we're probably going to find it about right there. But in the warm air mass, remember warm air tends to expand, it has a lot of volume, so we're going to have to go up higher to get to that pressure surface, and we'll find it up here. So if we connect up the 500 millibar surface, kind of see what's going on here. The surface deflects up to higher heights over the warm air, and even if we go up to 300 millibars, the same thing, the distance between 500 and 300 is going to be greater. In the cold air mass, it's going to be less. And so these surfaces become more and more sloped as we go higher and higher aloft. And that's the reason we have the jet stream. That's the reason why it's stronger as you go to higher and higher heights. So we tend to find it up here, between the cold and warm air. So that's one reason the thickness is important, and also thickness kind of shows us where the different air masses are. Let me go to that other frame. Now the lower thickness is going to be, let's do that frame right there. This here is going to be the cold air mass at this particular time. This is on the 28th, which is Sunday. It's expecting the deepest, richest, or the deepest, coldest polar air mass to be over the Northwest Territories here and over Hudson Bay. And the very core of that polar air mass is in the center of this lowest area of heights right there. So that's the core of the polar air. So this is positioned to like kick down southward, maybe into Alberta later on, and might get a polar outbreak through that area next week. Now where's the warm air? We have to go pretty far south for that. You can see that the core of that is mostly off in the Gulf of Mexico and Texas. So how do we find the front? We look for the tightest packing of the thickness lines. Okay, I don't see much packing of thickness lines down here. All we've got is red and orange here. But as we go further north, you can see there is some packing in here. So this suggests that there's probably a front on the warm side of that gradient. So I can kind of follow that along. There's another front. It looks like that curves up in this area. Okay, so that's our frontal boundary right there. And then now looking at the pressure lines, we've got a low pressure area right there. See, we go from 12 to 8 to 0. So that's probably a 998 millibar low pressure area here. And then we've got high pressure here across New Brunswick. What else do we have? Looks like maybe a little bit of high pressure here around the Four Corners. Then if we go further off in the Pacific, looks like there's high pressure out in this area. So that's way out there. So this is our next polar outbreak moving in from Alberta. And then this side's going to be a warm front here. So this is 3 days out. So just looking at the thickness and pressure, we've pretty much got the surface map in front of us right here. So bearing that in mind, let's start with the analysis for right now. Looks like some pretty good low pressure up in the Hudson Bay area. And looks like we've got a front coming into the Great Lakes. See, there's 3 or 4 shades of orange here in the central U.S. And the southern edge of it is down here, so that places the warm front through Kansas, so something like that. Then we find the warm front up near New Brunswick and Nova Scotia in the Maritimes there. So that right there is the surface analysis using thickness and pressure. And pretty good high building in from the Pacific. I forgot to look at the upper level charts, but we can easily do that in just a minute. Anyway, let's follow this along and see what the pattern does. Front kicks eastward, and then we have new low pressure forming in the Yukon. See that coming together right there. You're going to see the storm system coming together. By day 2, look at that, it's dropping south through Alberta. So warm front there, cold front here. By day 3, it's where I was showing you earlier. Then by day 4, looks like that recurves northeast. There's the cold front into the northern plains, warm front like that. Day 5, that moves on off this way. It looks like another front gets started in the Montana-Alberta area, so you see that right there. So it looks like a couple systems coming here through the Canadian prairies and Montana and Dakotas. And things should stay pretty calm down here in the southern U.S. But remember, we have to go to the precipitable water. That's going to show a different picture, I almost guarantee. Let's look really quickly at the 500 millibar chart. There we go. This is the 500 millibar chart for right now, or this morning actually. Looks like some pretty good high pressure aloft over the Pacific, and this is causing that unusually warm unusually warm temperatures along the Pacific coast. So we're getting a lot of very strong subsidence. 597 is that's very high for 500 millibar heights. I think 600 is probably the highest I've ever seen. So that's representing very strong subsidence across the northern Pacific. However, around the fringes of that, we've got a polar front jet diving south. Now, let's see. Now, watch this area up to the north in Alaska. See this gradient here between negative vorticity and positive vorticity? The colors are a lot denser and bolder. That represents a jet moving through this flow right here. So there's a jet max moving through southern Alaska. Now watch what happens. Day 1, it moves into the Juneau, trying to remember the town names, Yakutat, Whitehorse. It's right around there. Day 2, now you see it developing a deep low across British Columbia. And remember, on the surface charts, we were seeing that surface system coming together across Alaska and moving south. So these are linked together. This is the upper level support we're seeing right here. This is the shortwave that's driving that system. So that drives that system into Alberta on day 3. Day 4, that progresses into Manitoba, and then we get the next system coming on shore. So you see how all that's tied together. I didn't want to make that too long, but you kind of get the picture. Things very active across the Canadian prairies over the next few days. And that brings us to the southern plains, the precipitable water. Let's see what happens. Starting out at 0 hour. Look at all that right there over Louisiana and Arkansas. Very high precipitable water. That's associated with a strong, I guess, slug of moisture moving across Louisiana. So we can see it there in the moisture field. And that moves across East Texas tomorrow. So we're going to see rain chances go up quite a bit over the eastern half of Texas tomorrow, and probably as far west as Dallas and Waco and Austin. Then we get another chunk of moisture coming up into the southeast Texas area on Saturday. And it's still affecting the area over the weekend Sunday, so it looks like rain chances are going to be up in Texas, Louisiana and southern Oklahoma over the weekend. And that hangs around most of the first half of the week. However, I think some of this is going to be suppressed around Sunday, Monday, and Tuesday by high pressure aloft. I forgot to show that to you. Let me bring that back here. Let's look at 500 heights and vorticity for the southern U.S. Now look at the 591 line. See how large this area is? This represents high pressure and subsidence over the southeast U.S. Now on day 1 you can see that shrinks down. See how much smaller it got? So it shrunk down quite a bit, so we're going to see probably an increased chance tomorrow of rain around the periphery. And then by day 2, it still hangs on. It still is kind of receded out to the east, so we're going to continue the rain chances. Then day 3, it looks like it builds back in, so it looks like we're going to start cutting off a little bit of the rain on 28th. That's Sunday. Yeah, so Sunday things will probably start improving a bit. The better rain chances are going to be down south, it looks like, because the core of this upper level high is mostly over the central Mississippi Valley. So you're going to have to go down to Houston, San Antonio, and Austin to kind of get away from the effects of that subsidence. So Dallas and Oklahoma City should see things dry out a little bit. So there you can see the 500 millibar heights. You can kind of correlate that with your precipitation risk. When it expands, that tells you you have heights building, more subsidence affecting the area, and when it shrinks, then your precipitation chances go up. So you can kind of pair that together with this precipitable water. So on Monday and Tuesday, even though we have a lot of precipitable water, it's being suppressed to a certain extent by the upper level subsidence. So that can kind of cap things a little bit. And then we were looking at that system coming across Cuba. Where does that go? Let's see, it's very hard to find. It looks like it's in this area right here. No, it's back down here. In fact, there's that low pressure symbol. So let's see what that does. Okay, it's across Havana and Key West on Saturday night. Then it goes into the Gulf, just north of the Yucatan, right there on Tuesday. See, that's Monday night. And then it carries it onto the Texas coast. It looks like it's around here somewhere. It looks like it's opened up a little bit, maybe into like an easterly wave. So this is around Wednesday. So it looks like it's bringing the track kind of like in this direction towards Mexico. But that could definitely change. So we'll just, kind of watch that over the next few days. Okay, we've ran up to almost 30 minutes here, so this went pretty long. That's all I have, so I appreciate you watching, and I'll see you tomorrow night.